Hello all, today in this video I am going to provide a code regarding the naive-based machine learning algorithm. So as you may all know, in the first step we have to import the libraries which we are going to use in this code. So what are the libraries I am going to use are NumPy, Pandas, Scalar. And also in sklearn, what I am going to use is train test split. In the previous video, if you have followed the decision tree video, means in that to split the data set into train and split, I didn't use train test split library. Apart from that, I have used some other thing. So please check if you need any reference regarding that, please check that video. So now in this code I'm just using the train test split function, and to in order to display the performance metrics like accuracy, and if you also need some other classification report like precision recall and effort score, you can also call them using the classification report library. Then I'm just importing the data sets to call the iris data set. And finally, since we are using Naybase, and particularly in this video, we are just displaying Gaussian navies. So next, we can just run this libraries which we have imported. Then we can move to the dataset loading. So here we are just using the iris dataset, and just we are splitting it into text and train, x and y. X is the data displaying the target, and y is the data set having data type, and the y displays the target type. Then from this x and y we are just splitting into four tags like x train, x test, y train, and y test. For that we are just using the train test split library, and from that we are just calling the x y, and the test size we have declared as 3.3. Since we have given the training percentage as the 70, so it's zero point 0.3. If you want 80 means it will be zero point 0.2, and the random state as 1. So before that we can just run the data set to import it. And now gnb variable I have declared to call the model which is the nb, and that gnb model I'm just training it by using the variables x train and y train. Now for predicting it I'm just using the x test function. And finally, to just check the accuracy of the work, we are using y test and this prediction function. So now we can run the code. So in order to check the accuracy, we can just click this. It's our accuracy is 93.33. So if you need some other, if you have to test for some other training percentage, means that is 80, means we can here just changes as zero point 0.2. And now I'm running the code, and now I'm just printing the accuracy of the code. So you can see the difference. Previously with the zero point 0.3 it was, that is with 70% the accuracy was 93, and with 80% the accuracy is 96. So we can just check with 90% whether there is some increment or decrement in accuracy. So for 90% I'm just moving the test size as zero point 0.1, and just I'm running the code, and then we can check the accuracy of the naive base. You can see there is a wide difference. So as the performance is that is the percentage, training percentage is increasing, the accuracy is also increasing. So we can also check, previously we was having 70%, so now we can check with the 60%. For that we have to declare the test size as 4, and now we can run the code. So now we can just print the accuracy of this naive Bayes model. So I think definitely it will reduce. It had reduced, but it has not reduced to that much level, since with zero point 0.3 it was having nearly 93%. Now it may have some different percent, because as you all may know, sometimes the accuracy will be differ, but in this case it has not been differed. So with different test size, the accuracy for naive Bayes is differing. That's all with this code. So we can see to know some other basic Python codes. Please share. Please check our video YouTube continuously. Thank you.